Today's video will demonstrate the multiplication rule for independent event probabilities. So first things first, we have the probability of A intersect B is equal to the probability of A times the probability of B. This intersection symbol we could also imagine as an AND. So you could say the probability of A and B is equal to the probability of A times the probability of B. In this class, that's totally fine and acceptable to do. But sometimes you'll see that intersection symbol, and sometimes you'll see the word AND written. So in number one, if A and B are independent events with the probability of A equals 0.32 and the probability of B equals 0.85, find the probability of A and B. So what we're given here, we will have to write out the probability of A intersect B is equal to the probability of A times the probability of B. Okay, so I'll just put a multiplication symbol in between there. Now what we can see is the probability of A would be 0.32. The probability of B would go here is 0.85. So, and we're looking for the probability of A and B. Now you could note that with probability of A intersect B. So here we'll have multiplication. We need to do 0.32 multiplied by 0.85. So we can see here 0.32 times 0.85. I'm just matching up the colors so that we can follow it nicely. So when you type this in your calculator, we should get 0.272. And that will be our probability. Now we know that this is a correct answer because our probability must be between 0 and 1. If you get a number that's greater than 1 or a negative number, then you know that you have to check something out. Next question. If A and B are independent events with the probability of B equals 0.81 and the probability of A and B 0.45, find the probability of A, round to 3 decimal places. Now this one, if we rewrite our independent event formula, we can see here the probability of A and B is 0.45, so I will place that in this location. And then on the right hand side, we are given the probability of B, so I will place that there. And what we're looking for is the probability of A. So we will find that here. So let me highlight just to follow the colors around. So 0.45 will go here. Probability of A is unknown, but this is multiplied by the probability of B, which is 0.81. Now, in order to find the probability of A, we need to divide both sides by 0.81. And whatever you do to one side, you have to do to the other side. But the reason we do this is because 0.81 divided by 0.81 would cancel out and give you 1. So these cancel out, and on the right-hand side, you're left with the probability of A. On the left-hand side, we need to take our calculator, do 0.45 divided by 0.81, enter, and we will get 0.555 repeating, right? But if we round to 3 decimal places, the fourth 5 will round up that third 5 to 6. So we will have 0.556 is the probability of A. Okay, going on to the next one. Suppose you roll a fair 6-sided die, and then we'll flip a fair coin. What is the probability that you roll an even number and then get a heads when you flip the coin? So we have two things happening here, right? So imagine we have the fair dice, right? And then each side, right, is numbered as so, right? So on the fair die, we have the numbers 1 through 6. Now let's think about rolling an even number. The even number would be a 2, 4, or a 6 being face up, right? And then the other situation is, well, we have a coin. Now on a coin, you either have a heads or on the back side you have the tails. So you have heads or tails. With heads, that would happen 1 out of the 2 possibilities, right? Getting an even number happens 3 out of the 6 possibilities. But let's think about all of this together. Okay, now I know that these are independent events. Now, the reason they're independent is because rolling that die has nothing to do with flipping that coin, right? Nothing. They're totally separate. They are independent of each other. So if I asked you what the probability of, let's say, rolling an even, let's just say probability of E. I'll say E for the event of rolling an even number. Okay, so I'll just define that as E. The probability of E, this happens 3 out of 6. So the probability of that occurring would be 1/2. It happens half of the time. Now let's look at the probability of flipping a heads. So heads would go with flipping the coin here. I'll just look for the heads. Well, that happens 1 out of 2 times, half the time as well. But what if we want to do these together? We want the probability that you roll an even number and you flip a heads. Well, with independent events, you know that we could use the multiplication rule. So we could multiply the probability of an even, which is half, and multiply by the probability of heads, which is 1/2. And when you multiply fractions, you can multiply through the numerator. So 1 times 1 is 1, and 2 times 2 is 4. Now I'll show you something cool in your calculator. If you do 1/2 times 1/2, just using parentheses, and you hit enter, okay, 1/4 is 0.25. But if you hit the math button and you see number 1 as fraction, hit enter, it converts it to a fraction for you, so you could see that real nice and easily. So our probability would be 1/4. That's the probability that you'll roll an even number and get a heads when you flip a coin and roll the dice. So let's do this again. So suppose you roll a fair 6-sided die, and then you roll another 6-sided die. So then we know that we're looking at the numbers 1 through 6. What is the probability that you roll an even number with the first die? Okay, we saw that a little bit ago. Rolling an even number would be rolling the 2, 4, or the 6. So the probability of getting an even number would be 3 out of 6, which is 1/2. Okay, now the next part, and then we roll a number less than 5 with the second die. So let's look at all our possibilities. Let's list them out. So we roll a number less than 5. Well, what's less than 5? 1 through 4 is less than 5. So let's just say, let's pick a letter for that. Let's just say L for that, just for less than. So the probability of the event L, okay, so we just define this as event L, will be rolling a number less than 5. This happens 4 out of the 6, right? 4 out of the 6 possibilities on the die. Now, if we want to put this together, well, that first roll is independent, right? It's independent of the second roll, right? These are independent events, right? Independent events. Since they're independent events, we can find the probability of even and a number less than 5 would be equal to the probability of E times the probability of less than 5. So the probability of even would be 1/2 multiplied by 4/6. Now you could have simplified 4/6 to, let's see, 2 is uncommon, so 2/3. You could have simplified it to that as well. So 1/2 times 2/3. Now we know when we multiply fractions, multiply through the numerator. 1 times 2 is 2. Multiply through the denominator. 2 times 3 is 6. Well, this does simplify to 1 out of 3, because 3 goes into 6 twice, and 2 goes into 2 once. Also, another way to look at this, right in this multiplication right here, 2 over 2 really cancels, and you get 1/3. So 1/3 is your final answer. That also works. If you want to, you could just straight up use the calculator and do 1/2 multiplied by, I'll even put 4/6. I'll go back to what we originally, you can see 0.3 repeating is 1/3. But if you do the math, enter, it makes a fraction, you get 1/3. So yes, we did get the correct answer there. Thank you for watching my video.